All right. And there's actually two ways to do this. One way does involve, it's not division, it's not matrix division, but you have to use inverse operations, but we'll cover that. I think we're doing this, yeah, today and tomorrow. So you have tomorrow to work on this if we need to. So we're just going to work through a random problem to show you kind of how this works. It's pretty cool. Is it doesn't matter. I don't have to come up with a solution that's going to make sense or is going to work out. So you guys are going to go and come up with this. So I need a number. 7x plus 5y equals, give me a big number.
12.
Huh? That's not big.
1 million.
Maybe nothing.
2,000.
2,000. Sounds good. Okay, give me negative. Negative 3x plus 2y equals
1. Wait, no, we should go.
Huh?
We don't know.
We don't know. We'll go 500. That's all right. Not 5. Oops, sorry. I guess we'll go 5,000. Put a comma in there.
We know.
No, we'll find out. We'll see what works. Okay. So what we're going to do here is we're going to create a coefficient matrix. You remember what the coefficients are, what coefficients are. Coefficients, yeah. Coefficients are the numbers in front of the variables. Okay. Numbers in front of variables. So that's coefficient. So we're going to create a matrix that is 7, 5, negative 3, and 2. Now, the new word that you're going to have here is a determinant. Okay? So, evaluate the determinant of the coefficient matrix. I'll show you what to do. It's determinants. So here's our formula. And then we'll apply it to what we have up here. So the determinant of, let's say, matrix A. So if I have a matrix A, determinant, DET, is that prefix? Are you going too quick? Okay. The symbol that is used is kind of like an absolute value. Okay. So that's the difference. That's when you know they're asking for a determinant and it's not going to be a specific matrix. So it's like a big absolute value. There's no brackets on there. So this is still a matrix. A, B, C, D is still a matrix. But it's going to be an absolute value. And the determinant is the difference between the cross product. So I'm going to take A times D and then I'm going to minus B times C. So that's what the discriminant is. It's A times D minus B times C. Okay? So if I look up here, which one numbers are the A and the D? 7 and 2. So if I want the determinant of this matrix, it's going to be 7 times 2. So you're going to take this diagonal here, minus the other diagonal, which is going to be 5 times negative 3. 7 times 2 is 14, plus 15, we get 29. Okay. So this one, we're going to use this later. We're going to use this one later, so we're just going to hang on to it. So far, okay? So I'll end up okay here. Okay, so from there, we'll use that 29 later. We're going to replace the x coefficients with the answers. When I'm talking about answers here, the numbers after the equal sign. And then we're going to find that determinant. So we're going to replace the numbers that are in the x column, so the 7 and the -3, with the numbers that are after the equal sign, and we're going to find a new determinant. So it looks like determinant, vertical line, 2005, 5002. Did you see what I did there? And this is going to help us give our x value of our system of equations. So I took the x's out, and I put the answers in their place. Evaluate the determinant of that, so that'd be 2,000 times 2 minus 5 times 5,000. Negative 21,000. So it's 4,000 minus 25,000. So you get negative 21,000. So we're going to take this number. We're going to divide by 29. Where did the 29 come from? The answer to the coefficient, the determinant of the coefficient matrix. Now remember, we replaced the 2,000 and the 5,000 for the x column. If I take this divided by 29, that's going to be the value of my x value, where the two lines intersect. Kind of cool. So we know that x equals negative 21,000 divided by 29, which is about what? Yes.
Why did we add 14 and 15?
Oh, up here? Good question. You do subtract, but it's going to be subtracting a negative 15 because it's 5 times negative 3. So that gives us 14 minus a negative 15, which would change it to a plus. Yeah. If it was a minus, it'd be a negative 1. It'd work out pretty well. Okay, so that's what we get for x. I'm going to throw this up on Desmos once we're done and see if we got it right. Okay. So for x, backing up a little bit, remember we took the answers, the 2,000, 5,000, and we replaced the x column. because up here we had 7, negative 3. I replaced those two numbers with the answers, found the determinant, divided by 29. That was my x value. So for your y value, you're going to replace the 5 and the 2 with the 2,000, 5,000 and do the same thing. Find the determinant, then divide by 29. Okay, jumping around a lot here. So we're going to replace the y coefficients with the answers. Again, the numbers after the equal sign. We're going to evaluate the determinant, and then we'll divide by 29. Now don't think you're always dividing by 29. That's just for this problem. Okay.
We can't just plug it back into the top, or the top equation. Or you want
You can. You're going to get a more accurate answer because if you plug this number in, it's going to be rounded. So every time you plug a rounded number in, you get further away. If you want to deal with negative 21,000 over 29 as a fraction, you can. Okay. So like I said, this is going to give us our answers without having to plug them back in. Now if it's a regular plain old number, go for it. Once you get this down, it's 7, negative 3, 2,000, 5,000. Ooh. Big time. Bless you. Okay. Notice how I keep everything in order. The 2,000 has to be on top, 5,000 has to be on bottom. Yeah. That negative 3 is showing up again. So remember, if you minus a negative, it will change to a plus. Yep. Don't you feel smart now? Aren't you glad you didn't have to graph that to figure it out? By hand. Graph it by hand. Put that down. 7x plus 5y equals 2,000. Negative 3x plus 2y equals 5,000. Okay, I think we gotta zoom out a little bit. One line. Looking good. You can. You do have to show your work. Plus, we're going to 3x3 systems, so computer won't work for that.